Okay, so I know that was a lot to take in. So let's start from the very top. We have a total of 1,200 cases, and we're trying to sell these over the course of the year. So if we take the number of cases that we have in a single order and multiply by however many orders, then we should end up with 1,200 total. So we start off with this formula: X times R equals 1200. So again, if this is 1,200, then you can only have one order, right? If this is 600, then you have two sets of 600. If you have 100 cases per order, then you have 12 sets of those cases, right? That's how many orders you have. Okay, so X equals the number of items per order, and R equals the number of orders per year. All right, so let me break this down. We have our inventory cost, which is a combination of your ordering cost and your storage cost. Okay, it's both of those things together, your ordering cost plus your storage cost. So your inventory cost, I'm simply going to label that as IC of X comma R, and I'll tell you why it's XR in a minute. All right, so where does your ordering cost come from? We had that discussion. Okay, and let me show you that. Okay, each one of your cases of orange juice is $5. So you're going to take $5 and multiply it by however many cases you order. So X plus, you have to pay them $75 every time you place an order. So it's kind of like the Jimmy John's example with the tip. There's the $75. And so you want to take that entire thing and multiply it by however many orders you have. All right, so I'm going to take that and plug it right here. So this is 5X plus 75, all that times R. This is the ordering cost. So we're going to add to that the storage cost. Now we had a discussion about that as well, right? So your storage cost, they say it takes $8 to store each one of these, but you have to be careful because you don't want to put X in here, which would force you to be paying for the maximum number in storage. You want to cut it in half so that sometimes you'll have more in storage than you're paying for, and sometimes you'll have less. So plus 8 times X over 2. That is the entire inventory cost function. Okay? So now that we have that, we realize that it says right in the problem, they want us to minimize the inventory cost. Now we already know that in order to maximize or minimize things, we need to be able to do the 3-step process. Take the derivative, set the derivative equals 0, solve for your variable. The problem here is you have two variables, an X and an R, okay? So what you would like to do at this point is to make it so that you have a single variable. What are we going to do? We're going to go back up here and solve for the R. So why don't we divide this side by X and divide this side by X. And when we do, I'm going to put it right here, we get that R equals 1200 divided by X. I'm going to take this and I'm going to plug it in right there. Okay, so let's see, IC of something equals 5X plus 75 times 1200 over X plus 8 times X over 2. Now this is important because you'll notice that now I only have X's in here, so I should be able to take the derivative fairly easily, but now I don't have IC of XR, I only have IC of X. All right, so this is really important. This is a crucial point. Let me simplify this. IC of X equals, let's see, 5X times 1200 over X plus 75 times 1200 over X plus 8 times X over 2. Right, I'm going to put these 2 over 1 so the simplification can be easier. You put the 8 over 1 too if it makes it easier. So IC of X multiplying straight across. This is 6, 2, 3, x over x, plus, I don't know what that is, 7500, oops, 75 times 1200. I got 90,000 over x plus 8x over 2. You could go further. Notice the x's cancel, so you get 6,000 plus 90,000 over x plus 4x. All right, let me stop there. This is important. Okay, let me move that over so that you can see that.